let me quickly do the demo. So what we are seeing is a demo of an open source project where I am trying to control the facial expressions of Elon Musk. So as you can see, like this is a very cool and amazing application of deep learning. So yeah, let's get started. So can you see me uh, clearly and hear me clearly?
Yep, can see your screen and also can hear you.
Cool. So yeah, so let's get started on on practical tips on getting started with deep learning. So usually let's start with me. So I am Naman Mustafa, also known as the AI Dude on Twitter, and I'm currently senior machine learning in Autify. Previously, I have worked in Vision X, a local startup here in Pakistan, and I have also done bachelor's in electrical engineering from last. So as you can see, like I shifted from electrical engineering to computer science later, like after graduation. So that's an interesting journey. So yeah, the next, like you can find me on GitHub, Twitter, LinkedIn using my handle Next Alpha. So yeah, next let me quickly introduce the company I'm currently working. So I'm working in Autify. So what we do is we automate the QA process, like major hurdle in the QA process. So by like letting users quickly record the tests and get those tests maintained by AI, and this helps reduce a lot of uh, effort on the QA teams. So there are lots of like components in our product. Like there is no coding requirement. You can just automate the whole pipeline, and the tests are maintained by our AI. And we have like a very simple and easy to use interface. You just like let the system record, and then the AI maintains the test script, and the tests are on cross browsers, so it's very easy to use. Feel free to like sign up and try it out. So next, let me quickly share the some of the work I do at Autify. So yeah, I have like for the past year since I have joined Autify, I have done a lot of projects. So some of the key components that I have worked is image segmentation, then using evolutionary algorithms, and then like for reinforcement learning, nowadays object detection, and I have also applied graph neural networks. So these are like some of the different applications that I have developed within Altify. On the right, you can see the top GIF file is like showing the animation of a reinforcement learning algorithm being trained to like navigate the web. And on the bottom is an example of a semantic segmentation algorithm which extracts different components from the website screenshots. So yeah, that's about me. And yeah, next section, let's start with the what is actually deep learning. So uh, yeah, feel free to like ask a question anytime. So I will be monitoring the chat. So maybe like if you have any questions, I can answer them during the presentation. So yeah, next is the difference between artificial intelligence, machine learning, and deep learning. So this is like most common question I get asked usually. Like the general idea is that artificial intelligence is the class of algorithm that enable machines to mimic the human behavior. So any algorithm that's tries to mimic the behavior of a human being is comes under the category of artificial intelligence. So the next is like a subclass of artificial intelligence algorithm that's machine learning. So in machine learning, um, these algorithms are usually like where there is some kind of learning involved and we have data to work with. So any type of algorithm in the AI which requires data and some kind of learning is done. So that comes under the category of machine learning. And finally, we have the subset deep learning, which is again the subset of machine learning, and it encompasses all the algorithm. It only deals with the mostly deep neural networks. So we have like machine learning has lots of type of algorithms, and one of the algorithms class is neural networks. So deep learning deals with all the neural networks and their multiple layers of neural networks. So a quick example of like the difference between classical artificial intelligence and machine learning. So on the left, you can see an animation of a maze pathfinding algorithm, which tries to navigate the maze and find the goal. So there is no data involved, just the agent is trying out different outcomes and reaching the result. But on the right, you can see like if we have a lot of data, the key points on the graph represent data. So if we have lots of data and we want to like build a model of the data, like what does this data represent? So there is some kind of learning happening and we are trying to fit a line to the data so that like we have a better understanding of how data actually works. So this is like called linear regression, which is which is a type of machine learning algorithm. So the next usually commonly asked difference is what is the difference between like machine learning and deep learning? So we have the classical machine learning algorithms, which uh, where we, for example, you want to build an app where you want to recognize whether it's a person, like which person is it. So in classical machine learning, what the developers usually do is like build features. So for example, the distance between eyes, the distance between the line of eye and the mouth, and similarly the like width of the face, height of the face, and they feed these features to classical machine learning algorithms, which then finally recognize which like the output, what is the output. So in case of deep learning, what like people do is just simply take the entire image and put it into a giant neural network, and the result is like we let the neural network learn from lots of data, and we get the result. So that's like the main difference between like classical machine learning and deep learning. So yeah, so this is the next question, like why do we do deep learning? So this is one of the very common uh, uh, question asked. So first of all, it's cool. So it's stocks because lots of people are doing, there is cool breakthrough going on, and there is a lot of hype in this field. But more importantly, deep learning helps us solve a class of problems which were previously considered impossible or maybe like very, very hard to solve. The simple example is, as I mentioned, like if you want to differentiate between faces, so it's much harder to do using classical algorithms. So we rely on deep learning to solve such problems. So let me like quickly share the difference between like how does a traditional system is developed versus a machine learning deep learning system is developed. So on the left, you can see a diagram of a traditional application development where programmers writes a rule and he builds an application, and then this application is shipped to the user, and then user does like provided data and gets the output. And in terms of deep learning applications, so what happens is like programmer writes the rules and he builds like what's called a trainer. So what trainer is, it's a program, but it's a different type of programs. What it does is like it takes lots of data and it produces another program which then we ship to the users and user interacts with this program. So as you can see, like even though it looks a bit more complicated than traditional development, but there is one big catch. So that catch is this. So what ML engineer has to do is like just write the one trainer, and he can just provide different types of data sets to build different types of applications. So no need to write the trainer again and again. So for example, if you want to build an application which recognizes the digits, you just give it the lots of images of digits and let it train on the same trainer, and we have a digit recognizer app. So similarly, if you want to build an app which recognizes the letters, you give it to the trainer, and that trainer like learn the model and it generates a program that does the letter recognition. Now like the work is kind of like reduced in terms of development. So another key advantage of this type of application is, for example, if you want to record the edge cases, and usually edge cases, what happens is like if, for example, you have built an application, it does digit recognition, so but it fails sometimes. So what happens is like you build a fault system which takes the failed cases and gives back to you, and you like improve the data set and let the trainer run again, and it will build a newer model which is better, which is like compared to traditional development, it's much different because you a programmer does not have to write the code to fix the bugs as in like classical cases. Yeah, sure. Like, uh, I can share the slides later, so like everyone has access. Okay, so then deep learning. So this is uh, very important to recognize like when to use deep learning and when not to. So as you can see, like the right, it's usually lots of linear, uh, lots of math, and you just put your data into the math and you get the result. Sometimes it works, sometimes it doesn't. But it's very important to recognize which type of problems should be you be using deep learning with. So, for example, any problem that requires lots of data, so you can use deep learning. So, example is like face recognition, or you want to do text generation. So, there are like some tricks to reduce the data requirement, but in generally it depends on a lot of data. Then we have like non-determinism. So this is like one of the key thing that I had to realize is because when working with deep learning, I when building classical algorithms, we always have a system which is kind of perfect. Maybe like if, for example, we want to build a prime number generator, then there is no such thing as inaccuracy in our system. But if we have like some tolerance or maybe like failures are acceptable, then it's good to go with deep learning system because the failures are like part of the system. Even though like even if we reach 99% accuracy, the failures will always stay there. So the next is like there are lots of basic programming uh, like algorithms like prime number generator or like other type of algorithms where it's not like lots of people have applied deep learning to those, but it doesn't really work that great. So it's very important to recognize when to use deep learning and when not to. So I'm going to share like some of the key uh, rule of thumb that help that help you decide whether to use deep learning to solve your problem or not. So the key data structures or key data types uh, which on which deep learning operates are like images, text, audio, graphs. So if you are working with these data types, then it's recommended to go with the deep learning. So for example, if you want to build an image or maybe like any cross of these like domains. So for example, if you want to build text image to text, so example would be like captioning. Similarly, image to image, if you have used Snapchat filters. So text to audio is usually used in speech synthesis applications. Audio to text is an example is YouTube caption generator. So for example, if you have used YouTube seen videos which YouTube generates captions. So those are generated by like these algorithms which take audio input and produce text output. Similarly, if you have used TikTok, there is like music lip sync. So that takes like audio and video input and generates audio output. Many times you are using with these types of data structures, it's recommended to go with the deep learning. So types of problems. So it is also very important to know like which kind of problems we can solve. So it's very useful to realize that we can categorize our problems into one of like problems that deep learning can solve. So some of those categories are, uh, for example, if we want to differentiate between a, an image of a dog or a cat, or maybe a building a system which detects if a certain email is a spam or not. So this is like categorization or classification problem, which deep learning solves very well. So there are lots of literature on this. Then we have if you want to like build a system, for example, self-driving system, you want to understand like if you are taking input as a video, so you want to differentiate what's the load on the pixel, like on the image, what's sky, what are the different components in the screen. So it's very important to realize based on for the like if you want to build a system for like example self-driving car. So another like example is text parsing or text understanding. So if you want to parse your text or like see what's the meaning of your sentence or like what's the key components in your text. So usually deep learning works very well on these type of problems. Another powerful application is generation. So on the left, you can see is an example of generated faces. So these faces are not real, but generated by an AI algorithm. So it's very hard to like tell the difference between a real face and the generated face because these algorithms have become very good at generating images. And on the right, you can see an example of using GPT-3 to build a yeah, so the system is design writing code using GPT-3. That model, what it does is generates text. So you give it a sample text and it continues that text. So this is very kind of powerful model that uh, operates like on a text to text paradigm. So if your application involves generating text, so deep learning is very good on that. Another application that I'm usually very interested is anime generation. So on the left, you can see an application which generates a new anime from scratch. So this AI model is what it does is like generates very like realistic looking anime scenes and portraits from like scratch. So uh, there is no artist involved in drawing these scenes. And on the right, if your problem is like image to image translation or video to video translation, so as you can see, they are like taking one face input and generating another face with the same semantics. So it's very easy to do these type of applications with deep learning. So another very powerful application is like image to text and text to image generation. So on the left, you can see an image and the model generates a text description of that image. And on the right, you can see a model that takes text description as input and generates images which are like accurate compared to the their text description. So these images are neither like drawn by humans nor like any artist like guide these algorithm. Just a simple text description, and you have a lot of diversity and lots of samples that are generated. So this is very powerful application of deep learning. So these two like are uh, models by OpenAI. So they're very powerful. So yeah, so the next step is how do we do actually deep learning? So what happens is like uh, yeah, so the main difference that I usually like share when like differentiating between classical and deep learning uh, application development is the how we write code or how we understand programs. So in terms of classical application development, you just write a code in a common programming language. That code is compiled into machine instructions, and then machine runs that code. So it's kind of like instructions that are like there. So you give it kind of a recipe, and the machine follows those recipe. But in terms of deep learning, what happens is like as I mentioned, we build a trainer. So the trainer is basically a kind of a graph which is uh, kind of which acts as a like computational graph which takes data as input and generates uh, another program which we call model. So basically it's kind of one step more complex than simple development. So let me show an example. So if you want to build an app of a selfie to anime, so what you do is like you take you have lots of data. So then you build a model, which model is usually like a network or graph like this, which has lots of layers. You give it the input and it generates the output. And then we have a loss which differentiates. So for example, if you have these kind of pairs, if this is the selfie of the person, then this should be the anime selfie of that person. So you feed these two to the loss, and this way the whole learning happens. So this is kind of an example of computational graph during which like you provide lots of data, and you also like provide both like the your input and desired output, and then the network produces the target output which is like you expect. So at start it's very bad, just like as I shown here, but over time it gets like it improves and gets better. So as you can see, like it consists of lots of layers. Each layer is then like in simpler term, each every layer is something like a mathematical function with lots of parameters. So what happens is like these parameters A and B are usually like learnable, and then we have mathematical function. So it's good to know these like underlying concepts mathematically, and it's like usually very useful, especially if you are doing research. But if you are like enthusiast and if you are like trying to just use these concepts like build some cool applications, then it may not always be like very good idea to just get stuck on math. So I highly recommend just going with the building the apps using deep learning. So as you can see, like after you have like let the model train on your data, then you build a mobile app and just put your model on that. And it takes an image selfie of someone and generates an anime selfie that's related to it. So yeah, so this is like a general paradigm of deep learning systems. So the final thing that I want to mention is like you have to just do it because it's something that you learn more with more experience, and like it's good to have lots of ideas. Sorry, it's good to have the understanding in-depth knowledge of maths and statistics and probability theory. But if you do not have these in depth, then it's still possible to do deep learning. And especially like for people who are enthusiasts, it's very recommended to do it. Just gain experience in the field. So you over the time you learn uh, patterns, and it helps you like build the system easily. So next, I want to share like some of the resources, like where can you find deep learning resources. So there is like on Medium, you can find the towards data science Medium blog. There are lots of articles, useful articles from very beginners to highly technical, and you can also follow me on Medium as well. So on YouTube, there is like YouTube Yonek Culture. He posts a lots of research paper reviews and we have like streaming. So you can find like all of these resources in the slides. I will share them later. And you can also so Twitter is a great resource because there are lots of great researchers and research groups on Twitter. You can like interact and follow on Twitter. So I will share these later, so you can like follow them on Twitter. So next is like courses. So a lot of people like ask me what kind of courses should we take. So I have shared like some of these. So three of the main courses that I highly recommend. So these are like Deep Minds course on YouTube and MIT deep learning course CS231. So these are a bit more technical, but they are on practical side, not on the theoretical side. So those you can take those as well as like also Sasha mentioned the Lee Wagon. So you can also take the bootcamp. Besides this, there is one of the major challenges hardware. So you can take yeah. So hardware is very good hardware is required for deep learning. Uh, so you can take, there are lots of free resources available on Google, especially like Google Colab and Kaggle. So they both provide you access to free GPUs and DPLs. You can use them for your uh, projects. Similarly, I use Vast.ai a lot. They have a very cheap consumer grade GPUs. And personally, I also like Google Cloud, which has very good, uh, uh, yeah, so the Google Cloud has very cheap resources, cheap access to very powerful GPUs. And you can also build a personal setup, like people have built from $1,000 and it can go up $10,000 and maybe higher up. So for software, I highly recommend go with PyTorch because it's my favorite. But you can also get started with TensorFlow plus Keras stack, and we have Python. Uh, it's highly recommended because almost the entire stack of deep learning is currently on Python. There are some stacks available, especially in Julia or C++, but I would still recommend to go with Python because it's very simple to use, easy to uh, learn language. Then we have like GitHub. There are lots of useful resources on GitHub. You can find lots of pre-trained models. There are lots uh, of implementations available. And then like one of the challenges to have access to data sets. So I think Google search and you can like find cool data sets on Google search, and also like Kaggle is a great resource with lots of data sets. So yeah, that's all from me. So if you have any question, you can ask, or we can like maybe um, have a bit of demo. Maybe like I can share some of the how to use Google Colab. Maybe.
it's time to ask questions before we move on to the demo. Hey guys, feel free to shoot your questions and messages to the chat. If it's too long message, you can also unmute yourself and ask it. Cool. Looks like everything is clear so far. Very clear and not very clear at all.
Yeah, it can be both.
Cool. Probably we can move on to the demo and let's see if, yeah, if people have any questions after that.
Yeah, sure. Okay, so I have shared the link to Google Colab. So it's a free resource by Google. They provide lots of uh, they provide free GPUs, so you can just go there and sign up, and you can create a new Colab notebook. So so basically, like you can just have access. Yeah, so this is kind of a Jupyter notebook environment. If you have used Python, so this is very handy. So using like this runtime, so if you press on the runtime, you can change runtime, and you can select here GPU or TPU, and also like if you are booked for uh, Colab Pro user, you can also change the RAM. So if it's high RAM or like standard RAM, so I'm going to go with the GPU and high RAM. So uh, and you can just type it and run it. So you can run the cell by Shift plus Enter. So if you press Shift plus Enter, then it will run. It will connect you to the Google servers where they have free GPUs. So yeah, here. So you can see like it's working. Next, you can see if you have access to GPU, you can just type NVIDIA SMI and just run it. It will show that I have access to NVIDIA GPU with 16 GB RAM. So I can now build and train my model. So yeah, so there are like lots of ways to like build a model. So so in this demo, I'm going to show you how to like take a GitHub project and use that for our own demo. So there is a project uh, due to that. So what they do is like they they have built a model which extracts yeah, it's kind of a background cropping model. So you give it an image and it removes the background and only like the region with the like the main like object is remains and the rest of the is like blank. So we are going to use this model for our demo. So they have provided this model, so not this, yeah, this one. So let me quickly can access the file system on Google Colab through this files tab. So if you press, you can see all the files that are available on Google Colab, and then you can just and just uploading this folder. So in the meanwhile, you can also like uh, get their model. So there is also provided this portrait model that takes your image and converts it into portrait. But I'm going to show the demo of the simpler model, which is the background remover. So I'll just simply take out the model. So they have implemented uh, their model in this file. So you can just clone the repositories, or you can also just take their code tools and put it here. So this way, like the whole model is available, and I'm going to run it. Okay, so the good thing about Google Colab is that you have all the libraries and relevant stuff accessible. So you can just run the code and the whole libraries. Like there is no worry of installing libraries and nothing. Most of the things are already there. So Python responsive and everything. So I'm going to create a model. So they have provided. Okay, yeah, so is the voice better? So, yeah, I'm going to create a model. So let's say this is the default model that they have provided. So I'm just going to create a model. Yeah, so this way I can just run it on Google. If I just load model, so this is I'm trying to load the model. Now the model that I uploaded, as you can see, it's accessible here. It's loading. So next maybe like we can take some image and run our model on there. So let's start. I have written a command to just quickly download directly the server. As you can see, the download image will be created. So we can open it. So these are like all the functions of PyTorch. So you can like try out different boot camps or courses which teach you exactly like how to use these uh, features. So I'm just going to quickly use these functions to get the results. So as you can see, like now I have the image as a PyTorch tensor, which I can feed it to the model. So see their code if I am missing something. You can also like learn from their code or author. They have also provided lots of like usually it's available on their uh, GitHub repository. This is the normalization that they have used. So I'm going to use it as well. So pages the size 3 but we use this size to 320. So I'm going to size this image to 320 so that it's visible. Weight is to you can also like use the full code for like if you are building application, so you can just take the code. Also, like make sure to look at the license. So it's usually not always available for commercial application, but for learning, it's I think mostly okay. So I have like normalized the image. So next, so yes, I got the show it what's the output of the system. So you can work the as you can see, like I have given this dog image and it has produced this uh, kind of a mask. So if you maybe like multiply this mask with the image, so it looks if you read image, so it's a bit messy with some kind of noise here. But like you can also try out different ideas. I think that's so you can build an application like with these open source applications. So all you have to just do is look through the GitHub and find these two projects. They provide most of the like time open source implementations which are very useful. But if your system is like more complex, then you can also build it from scratch. So yeah, that's I think all from me. So if you have any questions, feel free to ask.
Cool. Thank you so much um, for the demo. If the audience has any questions about the presentation or the demo, feel free to ask right now. I believe you also want to share your presentation as you promised. Some people were asking in the chat.
Yeah, yeah. Let me quickly share the link. The question is, do we have to resize image to fix size? So it depends on the implementation. So I think the authors did train the model on a fixed sized image, so we have to follow it. But if they had trained it on variation, like different size of images, so it might have been possible to like run it different sizes of images. So yeah, it depends. Like maybe like we can try, but I like when I tried without resizing, so it didn't work that well. So maybe like based on the implementation, it may be recommended to try it the like given size. So I'm sharing the slides here in the link, or maybe like I can also know, give it to Sasha, or maybe like you can update share the link to participants. So yeah, that's
Yeah, definitely. I will also share it to our meetup participants.
okay. Yeah, also we have another questions about Java language. I guess this is rather an idea to start. Yeah, I think in my experience overall, Java is good, but like it has very limited support in terms of building AI systems. Uh, so, for example, if you are trying to build a model, custom model with very complex structure, so Python has a lot more complicated support for these things compared to Java. But I haven't personally tried Java itself myself, so not sure. So, but for mobile application, if you are looking like mobile application, so there are a lot of frameworks that help you like deploy your model. So you have to first train it in Python, and once it's ready, then we can like use JavaScript, Java, C++, C Sharp, any other language supported by like there are lots of frameworks that support the model deployment. So using those languages, I think it's possible to deploy the model, but for the training phase, it's very recommended to go with Python. So we have another question: what skills we need to gain or enhance as prerequisite to enter the field of I believe the primary skill is like programming. So we have to have a good understanding of programming. And other, like the most important skill, as I mentioned, is the experience. So you need both like the knowledge and experience. Some people, like some of my friend, what they did was to do take lots of courses, but like at knowledge level it helps. But if you are not doing like practical of those courses and like doing some gaining some real experience, then those uh, are not going to be very useful. So I would highly recommend like take courses, but at the same time like do take part in practical projects, workshops. Also like to engage on Twitter with AI researchers. There are lots of good researchers, and they also like share cool project ideas, which is very recommended. So there is also a server, Discord server. So let me quickly share the link if you guys want to join. So there are lots of cool AI researchers there who work on cool projects. So if you want to uh, learn more and work on cool projects, so I have shared the link to the Discord. You can just join, and yeah, it's very like good place to get started. I hope that answers your question.
Cool. We have 2 minutes left. So guys, feel free to share your last questions. Think also we get a lot of questions from people who want to get into data science and machine learning, deep learning. Do you need actually to do some publications in order to, let's say, get a job as a deep learning engineer?
I think in terms of research, so if you want to go into the research career, it's recommended to go with the publication, even like do masters or PhD. But like for example, if you want to be an AI researcher at top AI company like Google, Microsoft, Amazon, or maybe at some academia group, then it's highly recommended to have a publication in like top level conference. But if like I don't think most of the time masters or PhD is required. Having more experience, especially like hands-on experience on the key problems that are happening, and ability to read research papers, that's I think very highly required, and it like differentiates an average engineer versus like a top-notch engineer. So I know lots of researchers who like are able to quickly just read a paper and make its implementation. So that's very useful skill. So I think yeah, for publication, if you want to stay in industry, and mostly like ML engineer, it's not required. But for research, I think it's highly recommended, or maybe sometimes it's required as well. So yeah, I hope that answers the question.
Thank you.
Yeah, we have another question that getting experience that involve creating algorithms and such from scratch. Your experience always is it to get an with ML things like so. If I understand your question correctly, so like you mean creating ML algorithm from scratch. So I think yeah, if you want to usually most of the like 80 to 90% of the time we usually do not like we're not required to create machine learning models from scratch because these require a lot of research, and so that research does not directly like benefit, not always directly benefit the usually company or maybe environment. So usually what happens is like if you're working in startup or you want to produce value, so it's usually like it takes a lot more time to write your own network and then build your system on top of that. So it's very recommended to just go pick one of the top implementation and just take and use that for your application. And yeah, so the second part is like offering from Amazon and MS. So I'm not sure about masters because it's like academia helps at some place, like having the knowledge of probability theory and all those courses. But an offer from Amazon is would be of course a great offer, especially if you are being hired for as an machine learning engineer. So it's I think very recommended. So what kind of publications could be published? Any example? So publications like in terms of research. So if you want to get jobs, so there are like two, three different types of publication. One is the core research, where you basically build, do an improvement in the core structure of deep learning's activation function. So there is a lot of scope in the core deep learning field. So loss functions, probability theory, the statistical analysis. We have also GAN theory, reinforcement learning theory. So you can do some theoretical like improvements on the core of the whole deep learning field. And another very like useful and recent trend that publications got is the application papers. So there are lots of papers, research papers that came recently that are not a breakthrough in terms of core theoretical foundation, but rather they provide a framework for a certain type of application. So an example would be style game paper by NVIDIA, which if you I had also shown on my slides, which generates faces. So this is very powerful app paper, even if it's you know, even though it's more focused on application level, but it's so fundamental and so powerful paper that a lot of papers are building on top of this one paper. So this I think is very powerful side, especially like if you are in deep learning, so you can just uh, solve a problem and write a research paper on that problem. So there is a lot of scope in that. I hope that answers the question.
Cool. And if we have no other questions, I believe we are right on time. Thank you everyone for joining us and staying with us until that late. And thank you, of course, to our amazing presenter for delivering a very informative presentation. So I believe that you already shared your presentation in the chat. Good. So, because I'm going to wrap up event very soon, those of you who want to get access to the presentation, feel free to click on it right now. Make sure it opens somewhere in the window before we close. Cool.
Also, like if you want to get connected with me on LinkedIn, so I have shared my LinkedIn profile as well. So feel free to get in touch. And if you have further questions, so you can ask me there as well. Yeah.
Cool. Once again, thank you so much for your time and for your efforts and for your presentation. It was really nice. Also, for the rest of the audience, feel free to follow our events, our meetup group, because we have tech-related workshops and casual talks every week. Keep in touch for more interesting events like this, and good luck to you guys in learning deep learning. Thank you so much. Have a great evening for those who are in Japan, and maybe good afternoon for those who are in different time zones. It was very nice to have all of you guys, and bye.
Bye bye.